Good morning, students. Today we are going to discuss a new chapter, chapter 7. And the chapter 7 is your system of particles and rotational motion. Now the first topic which we are going to define is your center of mass. I think most of you know what is center of mass. A center of mass of a body is a point where whole mass of the body is supposed to be concentrated. I think most of you have checked the center of mass of an object. Suppose if you take a copy and if you can hold that copy at a particular point by your finger, then that point is nothing but the center of mass. Basically what happens at center of mass, whole mass is supposed to be concentrated. So according as per the gravity, the weight acts vertically downward. So if you consider the specific point as your center of mass, then whole mass is supposed to be concentrated, and if you multiply that mass with g, then whole weight is supposed to be concentrated. Now if you have to balance the object, what you have to do, you have to give a opposite force against the weight. So if you put a finger, you are not what you are doing, basically you are trying to balancing the weight. So if you can balance the weight by putting your finger at a specific point on the object, then that specific point is nothing but the center of mass. So as per the definition, the center of mass of a body is a point where whole mass of the body is supposed to be concentrated. Now in our topic we will consider two particle system. It means a system comprises two particles, and we'll try to find the center of mass, and later on we will go for the n particle system. Now let me go for the two dimension xy. You can consider three dimension also. So we are trying to define this as expression for the center of mass in two dimension. So xy coordinate is there, and you do have two mass m1 and m2 at a and b, whose position vector is your r1 vector and r2 vector. Now if you consider the system comprising two mass m1 and m2, then definitely you will get a specific point where whole mass is supposed to be concentrated, and let the specific point is at the position vector capital R vector. So you do have a system comprising two particles of mass m1 and m2, and you do have a particular point where whole mass is supposed to be concentrated, and the position vector of the position vector of that center of mass, or the point where whole mass is supposed to be concentrated, is your capital R vector. Now if you apply f1 vector and f2 vector on the system externally, these two are external force, f1 vector and f2 vector, external force on mass m1 and m2. So what will happen, basically in some internal forces also come. So f12 vector is your force on mass m1 by m2, and f21 vector is your force on mass m2 by m1. So if you have to define total force on the system, then total force is your external force plus internal force. Now basically internal force, action reaction, equal and opposite, so it balances out. So f12 vector equal to minus f21 vector. So if you consider the total force, then total force is nothing but is your f vector equal to f1 vector plus f2 vector. Now f1 and f2, you can use the equation of second law of motion. Basically force is equal to mass into acceleration. So acceleration is nothing but the change of velocity, and velocity is nothing but the change of position. So in the acceleration, basically you can express a equal to d square r1 vector by dt square. dr1 dt gives you the velocity, and dv vector by dt gives you the acceleration. So we have written directly for the acceleration d square r1 vector by dt square, and for m2 d square r2 vector by dt square. So if you take d square dt square and keep the other term within the bracket, then it becomes m1 r1 vector plus m2 r2 vector. So on simplifying, we have multiplied and divided by m1 plus m2, the total mass of the system. So m1 plus m2 within bracket d square dt square m1 r1 vector plus m2 r2 vector by m1 plus m2. So this is your expression for the total force on the system. Now total force on the system, and the simple system comprises two particles m1 and m2. So we have defined the total force by considering the particle available on the system. Now you can define the total force by considering the center of mass also, because whole mass is supposed to be concentrated at that specific point. So if you have to write the total force in terms of the center of mass position vector, then it comes out to be like this. Considering center of mass, f vector equal to m1 plus m2, because at the center of mass whole mass is supposed to be concentrated, and you can get the acceleration by double differentiating the position vector of the center of mass. So d square r vector by dt square. So 3 and 4, if you compare 3 and 4, F is identical, so definitely if you compare, then R vector is nothing but is your m1 r1 vector plus m2 r2 vector by m1 plus m2. So this is the expression for the center of mass. Expression for the center of mass means you can locate the center of mass by using the expression 5. So if someone asks you define center of mass, basically we intend to define the position of the center of mass or the coordinate of the center of mass. So in terms of vector, it is your r vector equal to m1 r1 vector plus m2 r2 vector by m1 plus m2. So if you have to go for n particle system, so m1 r1 vector plus dot 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 mn rn vector by m1 plus dot 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 mn m suffix n. So it is for n particle system. You can go for the sigma notation by putting the sigma I equal to 1 to n mi ri vector, I equal to 1 to n mi. So sigma I equal to 1 to n mi is nothing but is your total mass capital M. So I equal to 1 to n mi ri vector by capital M. So capital M is nothing but is your I equal to 1 to n mi. So differentiating equation 5 again, if you differentiate equation 5, then you will get the m1 plus m2 dr dt plus m1 dr1 by dt plus m2 dtr2 by dt. So you are trying to define the rate of change of position of the center of mass. It is nothing but the velocity of the center of mass. So v vector is nothing but is your dr vector by dt, that is the velocity of the center of mass, and v1 is your dr1 vector by dt and v2 is your dr2 vector by dt. So v vector basically gives the velocity of the center of mass. You can further define the acceleration of the center of mass by further differentiating with respect to time. So m1 m2 dv dt plus m1 dv1 dt plus m2 dv2 dt. So m1 m2 a vector, m1 a1 vector plus m2 a2 vector. So a vector is nothing but is your m1 a1 vector plus m2 a2 vector by m1 plus m2. So this basically gives you the acceleration of the center of mass in two particle systems. You can generalize for the n particle system like this. For n particle system, a vector equal to m1 a1 vector plus dot dot mn an vector by m1 plus dot dot plus mn. So under the note, if center of mass is at the origin, suppose if the center of mass is at the origin, then r goes to 0, no? So if you consider r vector goes to 0, then you can use two particle system m1 r1 vector plus m2 r2 vector by m1 plus m2 equal to 0. So it is here m1 r1 vector plus m2 r2 vector. Now further, if you consider two masses are identical, so m1 equal to m2 equal to m say, then you can further simplify this for two particle system. So m goes of r1 vector plus r2 vector by 2 capital R vector. So in terms of the component, as you are defining in two dimension, so r vector can be split up in terms of I cap and j cap. So x I cap plus y j cap, that is your capital X and capital Y for capital R, and small r1 x1 I cap plus y1 j cap, r2 vector x2 I cap plus y2 j cap. So if you use this expression for the two particle system, you can split the expression in terms of the component. So x I cap plus y j cap equal to m1 x1 I cap y1 j cap m2 x2 I cap plus y2 j cap. R1 vector we have considered x1 I cap plus y1 j cap, and R2 vector we have considered x2 I cap plus y2 j cap divided by m1 plus m2. So if you compare for I cap, then x equal to m1 x1 plus m2 x2 by m1 plus m2, y equal to m1 y1 plus m2 y2 by m1 plus m2. So please check this expression and try to find out your query. So please go through this part, and if you have any doubt you can ask. So this is all about for the topic center of mass, as we have started the chapter 7, system of particles and rotational motion. Thank you.